This is 2.8, Graphing Systems of Inequalities. So your essential question, how do you graph a system of inequalities? Just as we graph lines, we can graph inequalities. We still use the slope and the y-intercept. However, there are two extra things that we have to do when we graph inequalities. So I'm going to tell you, we're going to start off with lines, but we're going to throw in all the different graphs we did in chapter 1. But now we're dealing with inequalities. So we're going to have V shapes, we're going to have U shapes, we'll have straight lines, we'll have horizontal lines, and we'll have exponential functions. So you do need to know how to graph all of those things. But because we're looking at inequalities, not equations, we have to remember we have two things to look at. We have solid or dashed lines. Solid lines are when we have greater than or equal to or less than or equal to. That is a solid line. Okay? Or curve for our other functions. Then we have dash. That is greater than or less than. That is the dashed curve or line. Okay? And then we have shading. So we have to worry about graphing the function. We have to worry about the type of line we use for the function. And then we have to shade. So if you have less than or less than or equal to, that's where we shade below. If we have greater than or greater than or equal to, that's where we shade above. Okay, but it is a system. So when we're graphing systems of inequalities, it's only shading where the normal shaded region overlaps. It has to be where it's shaded for both, basically. So where's the overlapping shaded region? Because we're looking for the solutions to both, the ones that work for both systems. Okay, so graph the system of inequalities. If the solution exists, name 2 points in the solution set. Okay, so I'm going to set, I'll do one at a time. So I am going to graph this one in blue, this one in green eventually. So we look at our, we need to get y by itself, it already is. We look at our shift, shift is up 1. It's a line, so I'm looking at my m, my slope, which is positive 3. You could use positive 3 over 1. Don't forget 3 divided by 1 is still 3. But this is setting up rise over run. So I'm shifting up 1, up 3 over 1, up 3 over 1. I'm going to go backwards, down 3, left 1. Down 3, left 1. The reason I'm doing that is so I can have all the points to deal with. Now I have to think, is it dashed or solid? It's not equals to, so this is dashed. Okay. And we will eventually have to think about shading, but we'll worry about that later. Put my arrows on the end, and there we have our line. So the green one, I need to subtract x first. I need to get y by itself. Okay, remember how we normally set this up. Y is less than negative x plus 3. Put the x first, because that's where usually how it goes. Okay, so we look at our shift. Our shift is up 3. Our slope is negative 1. And it's not included, meaning it's just less than, so it's dashed again. Okay, so up 3, 2, 3. Down 1 over 1. Put a few of those in both directions, so I have a clear sight of where I'm going. And there we have it. So we have our 2 lines. Now we're going to deal with the shading. Okay, so this one is greater than, so shade above. This one is less than, so shade below. So I need to shade above the green, or sorry, the blue, and shade below the green. So shading above the blue means I'm shading the side that is, if I went on my line and I went up, that's where I'm shading. So notice that's this side of my line. I'm not shading it completely because we're only going to shade the overlap. So that side is where I would shade for the blue. My green, I'm shading below. So if I took a point and I went down, that's the direction I'm shading for my green line. Okay, so now we got to think, okay, where are these shaded regions overlapping? So it has to be below the green, above the blue. So that is this section right here. All of this area is our answers that work for both inequalities. Okay, so that is our solutions. So 2 points in my solution. I can pick any 2 points. So I can go right here. 1, 2, let's see, 1, 2, 3. It's kind of hard to see it. So like right there, that is the point -3, 0. That's one possible solution. Okay, I could choose any point. 1, 2, 1, 2. That point right there. 2, 2. As long as it's inside the shaded region, it works. Okay. Only points on solid lines work. So this point right here, and this point right here, and this point right here, they don't work because they are on dashed lines. If it was on a solid line, it would work. Okay. So number 2, graph the system of inequalities. We're dealing with lines again. If the solution exists, name 2 points. So this one will be blue once again. This one will be green. I already solved it for you. So this is an up 5 shift with an m value of -1 is included, so it's a solid line. So up 5, 2, 3, 4, 5, down 1 over 1, both directions. This time a solid line. Try and draw this as best as I can. And there we have it. The other one, this is a down 4 shift. M is +2, and it is also solid because it's equal to in the inequality. So down 4, 1, 2, 3, 4, always from the origin, up 2 over 1. Kind of want the point where they intersect, so that's why I'm going a little bit further there. That's my other line. Now we need where do they intersect. So this is shade above. This one is shade below. Okay, so I'm above the blue line. Remember, where it mean above, you go any point and move up. That's what direction we would shade. And I am below my green line. So where do those overlap? It is right here. All that space right there. Okay, so we need to pick a point. This time, remember, if they're solid lines, they work. So this point right here, those is a point on 2 solid lines next to the shaded region. So that point actually is one of my solutions. Because it's solid, it works. I could do any point along this edge or this edge of the blue or the green because that is what outlines our shaded region. And since it's solid, you're good. So that point is 1, 2, 3, 1, 2. I just noticed I made a mistake on the last one. So we'll go back to that in just a sec. 3, 2, and then any point on this. So I'll go right there. So that's 1, 2, 3, 4, 5, 2. Okay, my mistake I made is this point right here is not 2, 2, it's -2, 2. Some of you probably noticed that, but yes, that was supposed to be -2, 2 because I'm going left from the origin, so that is -2, 2. Be careful about that. Example 3. Okay, same thing, but now we're dealing with other types of functions. So still going to do 1 blue, 1 green. This is a down 2 shift, then a value of +1. And remember, this is a V-shaped. And we got to think solid. In this case, this one is a line with a down 1 shift and a m value of 2, also solid. Okay, so do the V shape first, down 2. And it's an A of 1, so up 1 over 1, up 1 over 1, making a V-shaped now, though. Notice you need to extend all the way to the edge of the axis because we need to be very specific with our shading. This one is a down 1 shift with a positive 2 slope. I'm going to go backwards a little bit to help me get that line in. Oops, the last point was right. Down 1. There we go. So kind of like that. They're both solid. Make sure you're careful about that. This first one is shade above because it's greater than. This one happens to be shade below. Realize we're not necessarily always doing one each of the shading. They could both be above, both be below. So shade above the V. So realize you go to your V and move up, just like before. That is showing you the direction of shading. So I would be shading above, up on the V, and shade below the line. So go to any point on the line and go down. Okay, where do those shading regions overlap? It's this like corridor right here that's slowly growing. They're solid, so I could choose any point along any of these lines. So maybe I'll choose this point right here as one of my solutions. It's solid, and it's outlining. They have to outline the shaded region, remember. So that's 1, 1. Okay, I could also go in at any point here, so we'll do this point right here, which is 1, 2, 1, 2, 2, 2. Any point inside the shaded region also works. Example 4, we have 2 new ones. So we have a horizontal line now and a parabola. So the horizontal line is at -1 and it is dashed. So dashed line at -1. Notice it's not it needs the arrows. It's not a asymptote. It is a horizontal line. This is a left 1, up 1 shift with an A value +1, so 1, 3, 5 pattern, and it is solid. So left 1, up 1, positive, over when I go over 1, up 1, over 1, up 3, following my pattern, right? Over 1, up 1, over 1, up 3, over 1, up 5. And then the same for the other side, over 1, up 1, over 1, up 3, over 1, up 5. Okay, and that one is solid. Careful about that. They don't intersect, but we're looking at the shaded regions, right? So this one is shade below. This one is shade above. So I'm shading below my horizontal line, shading above. Let's go to any point and move up. Where do those overlap? Nowhere. So the answer is no solution. It's not supposed to have an and in between. I'll erase that. It's no solution, period. There's no overlap. These do not have the same answers in any form. So there's no solution there. And the last one, number 5, we have 3 inequalities. So I have the first one in blue, the second one will be in green, and the last one will be in red. Okay, so blue, ooh, this is no shift, exponential. It's a b value of 2, and it's going to be dashed. Okay, remember for exponentials, it's kind of helpful to make this. So I'm going to plug in 1 and 2 because if I go to my key point, 0, 1, 1x value to the right is 1, 2x value to the right is 2. I plug in, I get a y value of 2 and 4. So from the origin, we're graphing points now, 1, 2, 2, 4. Okay, and remember there's an asymptote here. I'm not going to draw it in because I do have other graphs, but it's dashed like so. Got it. Green one, it's a line. So this is a down one shift with a slope of 1, and it is solid. Down one shift, slope of +1, and solid. Okay. And last one, x is greater than -1. So remember, x equals makes a vertical line. So this is a vertical line at -1, and it is dashed. It's not included. So x of -1, I'm going to make a vertical line that is dashed. Okay. And now we look at the shading. Where do these overlap? So I am below my exponential. So wherever you have a point, just move down. That would be where you're shading. I'm below my line. The last one, be careful. There's no below or above. We're not dealing with y. Y is less than, y is less than, y is greater. And notice everything has been dealing with y. Now is x is greater than. So for x, greater is to the right, less than is to the left. So this is shade right, because that's where the greater than is. So we need to find where all three overlap. Okay, so right here, the red and the blue overlap, but not the green, so that doesn't work. Right here, the red and the green overlap, and remember the blue is shading all of the stuff below, so it also overlaps the blue. So this is where all three overlap. All of this region here. Okay, and so if it's on the solid line that's outlining, we could use that point. So right there, 1, 0, that is a point I can use. I cannot use a point that's on the dashed line. So this line doesn't work. So I can pick another point on this line, the solid one, or I can just kind of go down here somewhere. We'll go right there. So that's 2, 1, 2, 3. 2, -3, because I'm going down. 2, -3. There's another solution. Okay, so you have your essential question. You need to remember answer that, and then write your 3-sentence summary.